Hello everyone, I'm Xiangli, a PhD student from Tsinghua University. In this paper, we introduce a fast IPv6 network periphery discovery approach. Using this approach, we find 52 million IPv6 peripheries, and many of them expose unintended services to the Internet. Besides, we present a routing loop attack, which affects at least 20 router vendors and 4 router OSs. And we received 131 vulnerability numbers. In the IPv4 Internet, researchers often use the network scanning approach to find devices, to uncover vulnerabilities, and so on. However, IPv6 brings in large address spaces and makes IPv4 style brute force scanning not workable. Researchers introduced kinds of techniques to discover active IPv6 hosts. However, these methods are not real-time and large-scale. We aim to discover the IPv6 network periphery from a new perspective, using the IPv6 address allocation principle. In the IPv6 Internet, kinds of devices need home router to access the Internet, and the SP usually assigns IPv6 prefixes, so each network is a public IPv6 network, and all devices have their public addresses. Among them, the home router, which is the last hop routed infrastructure, is the periphery we want to find and is more important. And there are many peripheries within the SP network. Besides, mobile devices can turn into peripheries by getting IPv6 prefixes. In fact, each periphery is assigned a public IPv6 prefix to construct its network. The attacker can send a packet to any addresses in the home network. If the packet hits the target, it will return a replay message. Then the attacker finds the targeted device. However, there is a large address space for generating addresses. It is nearly impossible to hit a valid target. Therefore, the home router will generate a destination unreachable message and send it back. In the end, the attacker can find the router by sending just one packet. Now, we can find one periphery. So to discover all the peripheries within an SP network, we propose to scan the IPv6 prefix space, that is, probing each subspace once. To evaluate our approach, we choose 12 SP's IPv6 blocks and scan samples prefix space. The scanning speed is less than 15 Mbps, and scanning each sample costs about 2 days. In the end, we find 52 million devices covering 3 networks. Then we focus on their security implications, including address space, privacy, exposed services, and the routing loop attack. First, US64 format addresses are criticized for a long time because they embedded devices MAC addresses into themselves and expose privacy issues. In our findings, there are still about 4 million devices using this pattern, including 62 devices vendors. Second, in the IPv4 network, services in the home router are invisible to the outer users. However, IPv6 bring the public addresses and make them open to the internet. For example, we find about 5 million devices open these services to the internet, and the top appeared windows are showing the following. Different routers show different openness policies. Besides, most software is released about 10 years ago and are affected by many vulnerabilities. For example, old version DS-MySQL and Dropbear is released about 10 years ago. Third, we find a new routing loop attack. In our threat model, the attacker can be in anywhere of the internet. For the home router, it is assigned an IPv6 prefix from its ISP, and the ISP router points the next hop to the home router. However, the home router just uses some addresses or sub-prefixes, which leave the next hop of not used prefixes to be the ISP router, which introduces routing inconsistency. So to exploit this vulnerability, the attacker can send a packet to any not used prefix, and the packet will be forwarded between the two routers until the hop limit is zeroed out, brings traffic amplification, and the victim router will return a time-exceeded message to the attacker. So to show how wide is the vulnerability and how many devices are under attack, we probe both BGP prefixes and 12 ISP blocks. We find about 5.8 million vulnerable devices, covering more than 3,000 ASs and 132 countries. As shown before, we received 131 vulnerability numbers because we just bought 99 devices, and all vendors confirmed the attack and are fixing it. Besides, we developed network scanning 2x map and open sourced it, and anyone can join. Then the mitigations. To avoid exposing peripheries, routers can block the IPv6 replay messages. Second, routers should strengthen access control policies and add unreachable routes for not used prefixes. Besides, IPv6 network strategies should be revisited. So that's all my share today. Thank you all for your attention.